Hello everyone, hope you all are doing well. In this video, we'll discuss the third problem of Leetcode Weekly Contest 297. It's the third problem and the problem name is fair distribution of cookies. It's a medium level problem. The problem says that we are given an integer array cookies where cookies of I denote the number of cookies in the ith bag. We are also given an integer k that denotes the number of children to distribute all the bags of cookies to. Now all the cookies in the same bag must go to the same child and cannot be split up. That means you need to assign cookies in the form of bags, that instead of assigning cookies we need to assign the bags to the children, right? And the unfairness of a distribution is defined as the maximum total cookies obtained by a single child in the distribution. So we need to return the minimum unfairness of all the distributions. Let's try to understand it with the help of the example. So in this case we have these five bags I would say, having the given number of cookies, and we have two children. So one optimal distribution is 8, 15, 8 and 10 and 20. So in this case, this student gets 31 cookies, this student gets 30 cookies. Now the maximum of these two is 31. So in this case, the unfairness will be 31. Now we 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 can see that any other distribution logic that we used among these bags will basically result in a value greater than 31. So that is why we return 31 in this case. If you come to the second example, we have three students and these are the cookie bags. So the optimal distribution that is mentioned here is 6, 1, 3, 2, 2, 4, 1, 2. That means each student is getting 7 cookies. So the maximum of all these three is 7. So we return 7. Now it can be shown that any other distribution will basically not result in a value less than 7. So in a particular distribution, we need to see that. So let's consider a particular distribution. So in that, each student will be getting some candies. Now what is the maximum candies a student gets? Suppose that is x. So we need to return the minimum value of x that we can get from a particular distribution, right? So that's the problem. So if we look into the constraints, so the length of the cookies can go up to 8. That means we can have 8 bags, and each cookie can have 10 raised to the power 5 cookies, sorry, each bag can have. And obviously the number of students is less than or equal to cookies of length, because we need to assign a bag to each student. Like no student can have 0 candies, so that means the number of students has to be less than or equal to the cookies of length, right? Let's try to understand it with the help of a with the help of a diagram, like how to approach this type of problem. So forget about this problem. Let's consider a case where we are given an array. We have an array, right? We are given an array. Suppose the size of the array is n. Now suppose the problem says that we need to select each element, like we need to select some elements from this array. Now if we consider the first element, then how many possibilities are there? Either we can select this element or we can ignore this element. So total there are two possibilities, right? What about the second one? Again, either we can take this element or we can ignore this element. Again, we have two possibilities. So this goes on. So for n elements, the total number of possibilities that we can have is 2 raised to n, because each element has two possibilities, right? So the number of possibilities of the distribution goes to 2 raised to n, because each element has two possibilities, or for n elements we'll have 2 raised to n. Now when we try to write solution for this one, so what we do, we traverse all the possibilities. Like we will have 2 raised to n, so we start from 0 to 2 raised to n, obviously less than that or equal to n minus 1. These are the number of possibilities. Now for each number represents here a possibility. Like for example, now if you consider the so here we are dealing with binary, we have just two possibilities. So how to represent a binary? We represent a binary in the form of 0 and 1. So these represent two possibilities, right? If we would have three possibilities, then how many basically numbers do we need to represent ternary, I would say, representation? So that will be 0, 1, 2, right? So for n possibilities, basically you need n numbers, n digits to represent different states, right? For 2, you need 2 bits, 0 and 1, to represent that okay, this is one state, this is two state. For three possibilities you need three states, 0, 1 and 2, so that these are the three states. For n, you need n basically states, so 0 to 2 raised to n minus 1, right? These are the possibilities. So that means each possibility will be of n digits, if I would say n digits, right? Obviously they can have trailing zeros and all, but roughly we'll be considering each number to be of n digits, right? So this is the thing that we approach. Now what we do, so suppose there is a possibility of 1 comma 1. Let's assume we are considering this case. So if it is 1 comma 1, that means we will pick the first element as well and the second element. Like suppose we have three elements. So if a number comes as 0 1 1, so this says that don't pick the first element, but do pick the second element and the third element, right? If it is 1 comma 1, if it is 1 1 1, then one says pick the first element as well, pick the second as well, pick the third as well. It's if it says 0 0 0, then it says don't pick even a single element. 0 1 2, all the three elements are 0, that means don't pick them. Okay, now if we take 0 1 0, it says that don't pick this first element, pick the second, don't pick the third, right? Here 0 represent don't pick that particular index element, and 1 represent pick that element, right? So this is the approach that we use in this type of problem. So we have understood how to deal with binary operations. Now in this case, it is not binary, it is represented by k. How by k? Because suppose these are the bags that we have, cookie bags, right? Now for the first bag, how many possibilities are there? There are k possibilities, because we can assign this bag to k students. Similarly for the second one also there is k possibilities, so for n we will have k raised to n possibilities, right? Now how many digits do we need to represent it? So the total number of digits that we will need is n, right? Sorry, the total number of digits that we'll need is k in this case, right? Because we are having k possibilities, so it will be 0 1 2 3 sort of to k minus 1. These will represent different states. Now the constraints say that k can go up to 8, right? We can have 8 bags and 8 children, right? So what will happen in the worst case? It will be 8 raised to 8. 8 raised to 8, yeah, 8 raised to 8. So in this case, how many states do we need? We need 0 1 2 up till 7. So actually what these states represent is that, uh, suppose when we pick up a possibilities, and if it comes out to be 2, so it says assign the current candy to this particular student, right? Assign the current candy to this particular student. Because now if it would have been 0, now how we calculate this? Suppose there is a number, I would say 8, 8 only, let's take. So this will be represented by, or to simplify the thing, suppose if we consider about the binary operations, so how we do? Suppose we have 3, so what we do? We divide it by, sorry, let's take first an easy case. Suppose we have 2, so what we do? We divide it by 2, it comes out to be 1 and the remainder is 1, right? So now, sorry, remainder is 0 and it comes out to be 0, and it is 1, so it comes out to be 1 0, right? It comes out to be 1 0. That means you keep on dividing the given number with the number of digits that you have, right? So in this case, suppose we have 8 and suppose the number is 7. So what do? You divide it by 8, so that comes out to be 0 and the remainder is 7. So that means the representation will be 0 7, right? The representation will be, in this case, not 0 7, actually that will be 0, and that will be, just a second, sorry for this, it will be 7 1, 8 plus 1, and just a second, let me erase it, let me erase it, yeah, just a second, yeah. So what you do, you keep on dividing it. Whiteboard seems to be hung, just a second. So you keep on dividing it, and then whatever remainder you get. So in this case you get a remainder of 7. That means we need to pick up the seventh element in the array, right? And once we are done with it, so we get 0, right? We get 0 because nothing is remaining now, because the algorithm says that take out the remainder and this is the index. Now you also need to divide it by 8, so that was 0, so the remaining is 0, so we don't do anything in this case, right? So whatever we used to do for binary, we will do it for k in this case, right? So that will be the core logic for this one. Let's come to the implementation part. The code will be pretty simple for this. If we come to the implementation, then we can see that, let me come here, yeah. So again, this is the number of elements that we have. The answer is assigned with a max value, just for the sake of simplicity. These are the two variables that I have taken for boundary cases. Now, what are the boundary cases? The first one is n equals to k. That means the number of bags and number of students are equal. That means you will assign one bag to each student. That's the only possibility. So in that case, you return the maximum candies in a particular bag. So we are taking out the maximum, right? The second possibility is that you have just one student. So in that case, you will be assigning all the bags to that student. So that is why we are returning sum in this case, right? These were the two boundary conditions. So that's why I tackled it differently. And now comes the core logic, where we were saying that for each position, for each of the n elements, we have k possibilities. So k raised to n possibilities. Now we start traversing each possibility. So what we do is that for every possibility, what we do, we basically have an array that how many candies are assigned to each and every student in the current possibility. Now the current possibility is j and index is n minus 1. We do this. What we do? What is the current student? It will be j mod k. We have k possibilities, right? So we assign the current candies to the student that we just got, right? The current index that we are traversing, and index minus minus, because now we have to do it for the next candy bag, and j is divided by k, because it is similar to the I would say left and right shift that we do in the binary cases, right? So we basically, that is division only, right? So that is why we do it. And finally, we have a variable that tells whether the current configuration is valid or not. We have a max value, because we need to take out the maximum candies assigned in the current configuration. Now we traverse the configuration. Now if the case comes where a student has zero candies, then it is not a valid configuration, so we just break our loop. However, if this is not the case, we keep on computing the maximum candies assigned to a particular student. Now if it is a valid thing, then we pick out the minimum of that, and finally we return it into the answer. So this is the core. This is the code for this. Now, if it would have been a binary thing, then instead of k, we would have replaced it by 2, and the code would have worked. So that's it for this problem. And the time complexity in this case is obviously exponential. That is k raised to n, and obviously some other things that we are doing. But overall, the majority of time is taken. So that is why k raised to n is the time complexity. We are taking some temporary space here. So we can also, instead of allocating it every time, probably we can take it outside the loop and reset the values every time. But it was a contest, so I was writing code pretty fast, so that is why I just ignored it. So so hope you learned something new from this video. Do support this video by giving up a thumbs up. Do subscribe to the channel, and if you have any queries, then please do mention that in the comments. I'll try to answer each one of them. And yeah, take care. See you in the next video. Bye bye.